Hello, this is Nisha,
This is Isaac.
and we're going to talk about our term project, which was programming the game Lights Out in R. Lights Out has a mathematical basis, which allows you to solve the entire game board using linear algebra principles. So, well, what is Lights Out first? Well, it's a game that was released about 20 years ago. It's a pretty basic game. It has 25 squares arranged in a 5 by 5 pattern, and when you turn it on, some lights will come on and some lights will be off, and your goal of the game is to try and get all the lights off, which is indicated by the title. So basically, the rules of the game is that when you press a light, the lights immediately above, below, to the right, and to the left will turn to the opposite configuration. So if they're on, they'll go off. If they're off, they'll go on. So with these rules in mind, there's a huge mathematical basis that goes along with this. You can find that in our write-up, which we will send as well. But in this video, we're going to be going over the R script. So that's in this section right here in our R code. So, okay, so the following R code solves a random lights out board configuration using Anderson's and Field's mathematical techniques from the summary section above. So first off, a random function is used to generate a 25 by 1 vector that consisting of zeros and ones. So basically this random 25 by 1 vector indicates the configuration of the game board in which 1 is on and 0 is off. So this chunk of code right here, rand function is the nums equals r binom from 1 to 25, 1 to 0.5, returns nums, is going to generate that 25 by 1 vector.
This chunk of code is just to plot what we got, to plot the 25 by 1 vector as a graph. So as you can see, the graph down below, when it's black, means the light is actually on. When it's white, it means the light is off. So the code here just these lines will set up the regions, and which there are for loops, which we're just gonna go over for every point in that matrix, and to test if the value is 0 or 1, and print the dot there.
Yeah, so a PCH of 15 is the black square, which is on, and the PCH of 0 is the white square, which is off. So basically, identifying those will allow the graph to be printed in such a manner. So moving on, now this is the function that actually accounts for the game mechanics. So inc is a function of x that switches the light on or off. So numerically, it would just change the value from 0 to 1 or vice versa. And then tog is the toggle function, which takes a point and switches it from on to off or vice versa, and then switches the points immediately above, below, to the right, and to the left, if possible, to the opposite configuration. And this tog function will return a 5 by 5 matrix, which it then turns into this, which togvec is a 25 by 1 vector, which will go back into another part of the code in order to be solved. So right here you can see that, so like if I is less than 5, then the component to the next column over, or the next row down will be changed in configuration, and right here it's the row above, and etc. for the columns as well.
And so the next chunk of the code is for to build a matrix A. Is going to be a huge 25 by 25 matrix, and the first row is going to be the toggle matrix, the toggle vect, the first toggle vect. So which means if you just run this huge matrix A is going to represent every possible toggle. If you choose, for example, if you choose like 2, 1, it's going to be the 6th element, and if you're gonna multiply a and x, it's gonna give you a matrix where the sixth element is pressed.
Okay, so the next function is a function called solver that takes a mod 2 matrix and reorders it into row echelon form. So basically it follows the algorithm for putting any matrix into row echelon form. So you move the row, the first pivotal one, to the top. Then you rearrange the rows so that they have pivotal ones in corresponding columns. And then you move all the 0 rows that you don't need to the bottom. And then once you have it in row echelon form, you can use back substitution to convert it into row reduced echelon form. So basically, as the math summary in our markdown file details, the last column of the row reduced echelon form matrix will be x, which is the solution vector. So, and this can be converted into a 5 by 5 matrix. So basically, going through this code,
So the first part of this code is just to switch all the non-zero rows to the bottom, and you have no idea how to explain it, but I think this code is quite clear because if you can see it's gonna identify if the pivotal, if the one place, the diagonal place is 0 or not, and it's going to rearrange use r-bind. The next part is and we're just gonna perform back substitution. Because we are doing in mode 2, so actually I just used minus here, but it's the same thing. So this code is only going to work for this special case. And the last column of a matrix is going to be our answer, and so I'm just gonna take that column out and make it into a matrix and return that.
okay. So finally, we have to indicate the matrix that represents where you hit the lights such that the board will be solved. So basically, again, as the math section in our markdown file details, the product of the elementary matrices when reduced will yield the matrix that shows where to hit the lights such that you can solve the board. So basically, you take the elementary matrix, which is formed by C binding A and B, and when you row reduce it completely, you'll get the solution, which it's right here. So basically, this matrix right here represents the buttons that need to be pressed such that the board will be solved.
By the way, in this part, C bind A is the gigantic 25 matrix, and B is our board. So it's the initial condition.
Okay, so right here is the part that actually animates how the board would be solved. So we have it in the R console right here. So we're just going to hit code, run region, and run current chunk. And then it'll be solving right here. Yay, it's solved. Sometimes it doesn't solve, but we got it to solve this time. So, yep, that's the R code for this project. And we hope you enjoyed it. Thank you.
Thank you.